Once the connection box is wired to the ignition, all user interaction occurs via the control pendant shown here. The flashing green lights indicate normal firing, but if the user activates the kill switch, a sequence of misfires occurs according to the user control settings. These settings consist of a thumb wheel, a 3-position toggle switch, and a momentary toggle switch. The simplest mode to demonstrate is periodic, set by placing the toggle switch in the up position. In this mode, misfires occur at a fixed period equal to the thumb wheel setting. Thus, for this 6-cylinder engine, a period of 006 means that the same cylinder is misfired every cycle, indicated by the location of the flashing red LED. A momentary hop switch allows the user to move forward or backward in the firing order. The misfiring cylinder remains unchanged regardless of engine speed or whether the ignition strategy is in regular or multi-strike mode. Multi-strike refers to a series of sequential sparks within the same cylinder for a given combustion event. The MisGen logic counts all such multiple sparks as 1 for the purpose of determining the period between misfires and for disabling all multiple sparks for the combustion event that is scheduled to be misfired. In other words, the user need not know whether the ignition strategy is operating in single-strike mode, multi-strike mode, or changing between them. In order to more easily visualize operation of the misfire generator with other settings of the pendant, I am running the misfire generator from an ignition simulator, which allows this virtual engine to rotate much more slowly than a real engine could. Thus, it is easily seen that using a periodic setting of 7 causes the misfire to occur 1 cylinder later in the firing sequence, while a period of 5 does the opposite. In fact, any period that differs by 1 from a multiple of the number of cylinders causes the misfire to walk across all cylinders in turn, whereas a period equal to exactly a multiple of the number of cylinders always misfires the same cylinder, though not every cycle, as seen here. On a 6-cylinder engine, a periodic setting of 018 causes a misfire on the same cylinder once every 3 engine cycles, since 18 firings equals 3 engine cycles. Note that a walking periodic mode accomplishes the 2 goals of the regulatory misfire pattern known as random misfiring cylinder on fixed cycle intervals. 1, it spreads misfires evenly across all cylinders, and 2, it creates a precisely known rate of misfire. In this example of 019, the misfire rate is 5.3%. Nevertheless, this is not exactly the mode specified in the regulation. So to accomplish that, move the toggle switch to the center position, which is called periodic with random cylinder misfire. Of course, the randomly selected cylinder means that misfires are not spaced periodically, but only uniformly with respect to the number of engine cycles. Thus, if I wanted 1 misfire on a random cylinder to occur once each 3 engine cycles of a 6-cylinder engine, I would set the thumb wheel to 018, which is 3 complete engine cycles. The thing to remember in this mode is to set the thumb wheel to the number of firings associated with the desired number of engine cycles, not the number of cycles itself. In doing so, the misfire generator behaves precisely as the regulations specify in tests to establish the detection threshold for emissions. Of course, the threshold levels are much lower than the current example, closer to 1%. So the user might choose, for example, 14 cycles of a 6-cylinder engine, or 0.84 on the thumb wheel, for a misfire rate of 1/84 or 1.19%. For these low rates of misfire, the pattern becomes much easier to visualize if we speed the virtual engine up again. The last misfire mode is truly random, which can be more difficult to detect than the other patterns, but is seldom used by engineers for 2 reasons. First, it is not explicitly specified in the regulations, and second, it produces a misfire rate that fluctuates around the set value according to the laws of statistics, which limits its practical use to only those tests in which the synchronized kill signals are recorded along with the data, a seldom used practice due to the complexity of doing so properly. Nevertheless, for completeness, I demonstrate this misfire mode with the following explanation. The thumb wheel setting signifies the probability of each combustion event being misfired, regardless of any misfires already induced. It is analogous to flipping a heavily weighted coin, wherein heads means normal combustion and tails means induced misfire. The thumb wheel is the probability of tails, that is misfire, with an implied decimal point between the center and rightmost digits. For example, a value of 0.84 means that each combustion vent has an 8.4% probability of being misfired. Note that if you were to increase this value, that would yield more misfire, whereas in the other modes, higher thumb wheel settings increase the interval between misfires, yielding lower percentage rates. By now, you have probably wondered about the existence of two identical sets of controls on the pendant. Each set behaves according to the previous description and operates independently of the other. One purpose for this redundancy is to allow the operator to set up two different misfire patterns beforehand and activate each pattern sequentially during tests without taking his eyes off the road. For example, I set a periodic misfire on the left controls and a periodic with random cylinder misfire on the right control. Then I can easily switch between the two modes of operation. Another purpose for the redundancy is to operate both patterns at once. The most trivial case is creating two dead cylinders each cycle with fully adjustable spacing between them. This example shows cylinder 1 misfiring and another cylinder located 2 positions later in the firing order also misfiring. Hopping one or the other of the misfires allows any pair of cylinders to be misfired, not just those occurring one revolution apart. Of course, if only the latter is desired, a single periodic misfire with a period set equal to 003 will create the desired effect much easier. More information is available about the misfire generator equipment in the instruction manuals that come with it and from Global's website, as well as by contacting technical support at Global Electronics directly.